My dear student, this is KB here. As you know, this is the platform where you can introspect about JEE NEET preparation. Today we are going to discuss about JEE previous year's problems based on work, energy and power. So see how we can solve and what is the level of questions which has been asked in past exams. See, this is the first JEE 2021, and in this question a figure is given and one of particle of mass 10 kg is resting on at point A and it starts to move on this frictionless track and it goes at point B. Then you have to find the speed of particle at point B, height initial given and final height, that is at point B, and from this surface height 5 meter is given. So this is a question of integer type question. You no options, only you have to put the answer in integer form. So you have to calculate the answer here. So how you can do it? This is frictionless surface, so we can apply the conservation of total mechanical energy, and you know the conservation of total mechanical energy TME at point A must be equal to TME at point B. So we can apply this one, TME at A, TME at B, and that is a speed of particle at here 0. So 0, that is potential energy, and this one is reference point, reference line, and you can also say that is datum line. With respect to this line you can find the potential energy at point A, that is mg h1 given, h2 given, and a speed of particle at here suppose that v, so half mv square mg h2. Say m cancel. Now you have to find a speed of particle at point B. So you can write here half p square g h1 minus g h2, and that implies g h1 minus h2, and that is 10 into h1 minus h2, that given h1 10 minus 5, that is 10 into 5, and that implies we can write here v square is equal to 2 into 50, and that is 100, and this is given by v 10 meter per second. So this is a speed. So answer will be, we have to put in computer the value of v 10 meter per second. So speed at point B will be equal 10 meter per second. So answer will be here 10 meter per second. This is the speed of particle at point B. This is question 2, JEE 2020. It has been asked in JEE 2020 this question, and potential energy is given between two molecules like minus A upon R6 plus B by R12. Then at equilibrium separation between molecules and P we have to calculate in this question. See, in question it's saying that there is a equilibrium. So in equilibrium you know force must be equal to 0 and potential energy is given. So with the help of potential energy we know we can find force. So see, on that basis we can solve this question very quickly. See how we can solve it. Here potential energy given, so F must be equal to minus du upon dr, and if we talk in magnitude then you can do modulus of that. So this one will be equal to 6a by r7 minus 13b 12b by R13. So this one is for equilibrium. Here equilibrium is given, so for equilibrium what you can do, F must be equal to 0 at equilibrium. F must be equal to 0, so this one 6A R7 minus 12 B R13 0, and that implies we can write here R12 and 6, we can write 6A, and that is 6A R7 must be equal to 12 B R13, and that implies we can find R must be equal to 2B by A 1 upon 6. So this is the value of R. Now we have to find at the value of this equilibrium we need to calculate potential energy. So at the value of this R we can find the potential energy here. So see potential energy, how we can do it. P, now PE now P potential energy at R is equal to 2B by A 1 by 6. So potential energy given like minus A by R6, so 2B, you can put here 2B by A, that is 6 into 1 by 6, and that is B by R12 2B by, this is 2B by A, that is 1 by 6 into 12. So we can solve this and we can get minus A square by 2B, just cut 6 is 2B, and this will be equal plus A square by 4B, and take LCM, so you can get minus A square by 4B. So this is potential energy minus A square by 4B. So this is a bit calculation, there is a bit calculation, but this is a straightforward question. And now you got potential at R we got at equilibrium. So R 2B by A 6, that's fine, and U 2B by 6, U minus A square 4B minus A square, yes. So option C is. There is 2019, it was based on the graph as shown in figure, and graph is given between force and distance. Force is given and force depends on this distance. 2 meter force is constant, but after 2 force varies, and 3 meter. So what we need to calculate in this question, we need to calculate a particle starts from rest, we need to calculate kinetic energy at point 3 meter when particle travels 3 meter. So how you can do it? We can calculate acceleration and everything with the help of distance, and you can apply the equation of kinematics, then we can apply the formula half mv square, but not like that. Here we know work done by forces is equal to change in kinetic energy, that is work energy theorem. So we can apply here work energy theorem, and that work energy theorem is nothing but is a work energy theorem like work done is equal to change in kinetic energy. Work done by forces is equal to del K E, and del K E, you know here del K E nothing but here initial speed 0 and final like Kf minus Ki is 0, and that is equal to work done, and work done you can write F dx, and integration you can put a variable force is there. So this is nothing but it's what, this is area, this integration gives area of force versus distance. So here you can find area of this total graph. So it will give work done in during 0 to 3 meter. So see how I calculate area here. If first divide this rectangle like this, and you need to calculate this area total. So area will be 2 this one and 3, 2 into 3 plus triangle area this one half. You can write here area 2 into 3 and plus triangle half into this base is 3 minus 2 1 and height is 1, so it would be 6 and 0.5. So you can write 6 0.5, so 6 0.65, and this is a work done, so it will be in joule. Now Ki is here because particle starts from rest, so you can find Kf, and Kf, that is final kinetic energy, minus 0, that is 6.5, hence Kf is equal to 6.5 joule. This is the answer. This question JEE 2018, and this is based on a particle is moving on circular path of radius a under action of an attractive force and potential energy given minus k by 2 r square, then total energy is k, 4 options given here. Again potential energy given, and there is attractive force. So you need to calculate total energy of particle. Total energy means kinetic energy plus potential energy. So here particle is moving on circular path like this. This is radius, suppose r, particle is moving on this. So you know force, centripetal force will be F, that is mv square by r, and that F is attractive force. So F is equal to d by, and you can apply du by dr, that is mv by r, and differentiate this one. So mv square by r, we can write u is given minus k by 2 r square. So differentiation of that, I mean d k by 2 r square minus by dr must be equal to, this one is equal to k by r cube. K by r cube, that if we differentiate then it k by r cube. So half mv square we got here, mv square is equal to, you can find k by r square, k by r square, and we need to calculate kinetic energy here. From here you can find k, that is multiply both sides with half. So half mv square, we can write half k, half k by r square, k by r square, multiply both sides with half, so half, this is a k. Now P is given, that's, and total energy, you know total energy here, total energy, total mechanical energy, that is energy, that is P plus k, P plus k, and we can find that P given minus k by 2r square, and this one is half k by r square, and this one cancel, so it's a 0. So total energy we got 0. So option C is correct answer. This is the last question, 5th, and which has been asked in JEE 2017. In this question, force is given, F is 60, which is variable on time, and after 1 second we need to calculate work done by this force. Mass is given, body starts from rest position. So how we can solve it? Here force is given, so we can calculate acceleration, we can apply kinematics, and we can do from that. But if we apply work energy theorem, then we can solve very quickly. Like see, force given, mass 1 kg given, and second force that is given 60, and u 0 and t that is 1 second. So F 60, and now we can find F ma 60, and that is m1, so a must be equal to 60, and that is dv by dt is 60, and we can find dv by dt. So dv we can write here 60 dt. Now integrate both sides. Initial speed is 0, final v t1, and that is t0, this is 1, and this v we got, and 6t square by 2, that is 3, if we put one value here. So now we got v, so you can find final kinetic energy half mv square, just multiply here m is mass mv square. So what will happen, this would be 9 upon 2, and we can find 94.5. So this is the final kinetic energy of particle. Now apply work energy theorem, because we need to calculate the work done by this all resulted force. So work energy theorem says del Ke must be equal to work done by all forces. Del Ke means Kf minus Ki, that is del W, and that implies del W you can write here Kf, that is 4.5, and Ki, that is initial speed, is 0, so kinetic energy will be 0. So that's why you can put here the value of Ki, that is 0, so 4.5 joule will be answered. So this will be answered. So this we can apply here work energy theorem, and we can solve very quickly. So thank you so much for this session.